Hi friends, in this session we will going to do the data analysis for CRD design, and this is for the equal number of replications or observations or plots. Okay, this design for 2 replications and 29 treatments. Okay, so in this session we will going to do the data analysis, how to do the data analysis in Excel. Okay, so you can see here character name. So you should have to mention the character name over here, like plant weight, number of branches, whether it's primary or secondary. Likewise, you can give the any character or parameter name here. Then below that, you can see here the treatments, 29 treatments, and replication 1 and replication 2, because this is the equal numbers. So we can consider the R1, R2, because if we consider the T1 having R1, R2 and T2 having only R1, this is falls under the unequal number of replication. In next few series we will going to see the how to do the unequal number of replications or observations or plot. Okay, in this session only we will consider the equal number of replication. Okay, so you should have to give the data like this, otherwise if you don't have the data in this sheet, okay, this type of sheet you will get, because this is a paid Excel sheet. If you want this type of Excel sheet for your data analysis, then definitely go to the description box of this video and you will get the Excel sheet. Okay, you ask me my WhatsApp number in description box. Here is two method to give the input of your data. You just put the data by manually like this, whatever data you obtained from your research. Then next, if your data in Excel, then you just go to your data, just select, then copy, just come to our design, select first cell, right click, and you can see here the paste options. Only you choose the paste option as a values. Okay, please remember only values. Okay, you will get all the values up to 29 treatments. Okay, and you can see already I highlighted this is the input values in red color, so you need to only change the red color values. Don't change any other values or any other formulas, and don't try to modify or alter the formulas. Okay, if you will get the sheet, you need to only change this value. If your advisor asks to make the changes in treatment number 19, make it 250, then you are able to do a real time. You can see here the reflection. Okay, because this is a fully automatic design, so you need to only change the red color values and don't change any other formulas and values. Okay, so next I will explain what exactly you will get from this Excel sheet. So listen carefully or see here on screen carefully, because once you purchase, then there is no refund. Okay, so whatever things you need, you can see here, you will get everything. And if you want anything additional point in this Excel sheet, then definitely ask me, I will add that, because it's a fully customizable sheet, because we made this type of sheets. Okay, so you can see here that you will get the treatment totals, then treatment average, we call it treatment, you can see here the mean. Okay, below that here you will get the grand total value. Okay, so we don't consider the replications in the CRD design. The very important table, that is ANOVA table. Okay, I'll explain what you will get in ANOVA table. Source of variation, you can see here the treatments, error and total. Then degrees of freedom, you will get the degrees of freedom. Then sum of square, mean sum of square, F calculated, F table. Then significance and F table for 1% and significance. You can see here you'll get this design for 1% as well as 5%. Okay, so if you want here the probability values, then definitely ask me, I'll add the two columns over here, and I'll add the probability values as well as the F table values for you with the significance. Okay, if you want, otherwise this is sufficient. Okay, Below that you will get the correction factor. You can see the correction factor is required for the calculation of the sum of square. Then CV value, few points about CV value very important. This is always in percentage. Okay, this is very high, so we need to make it for lab experiment or polyhouse experiment, this is less than 5%, and for field experiment it is greater than 5% and less than equal to 20%. Okay, please remember this point, this is 20. Okay, so after that you will get the standard error mean, standard error difference, then CD value at 5% and CD value at 1%. You remember one thing here. Sorry, if your treatments are non-significant, then don't go to the analysis of CD value. Just put in your thesis NA value. Okay. If your treatments are significant, then you need to calculate CD value, and also you need to calculate post hoc analysis. If you want any information about the post hoc analysis, then definitely ask me in the comment box, then I will answer your comment, or I will make the videos on the post hoc analysis. Okay, how to do it. After this you will get the final table for the thesis. You can see here the whatever character you chosen, you will get the treatment details here. You can put the treatment name, just copy paste, and you can paste to the thesis table. Okay, you will get the mean, that is the average. Below that you will get the graphical data representation. Just give the character name like plant height, then plant weight like this. And then here is the axis title at bottom. You will get the treatments here, and vertical you will get the character name, whatever character you choose for analysis. If any query regarding this or any query regarding the data analysis, then definitely ask me. I'll answer all your queries. Thank you so much for this session.